So our next speaker, he is the Director Promotion Directorate at InSpace. He is also working as Executive Secretary at Astronautical Society of India. Before joining InSpace, he was heading the GEO Control Dynamics Design Division and working as Deputy Project Director for Attitude and Orbit Control System at URSC. He joined URSC in 1997, when he has been involved with design and development of attitude and orbit control systems for over 3 dozen satellites in the last 25 years. He has also developed autonomy for GEO satellites, which has become the backbone of ISRO's fleet of spacecraft, including Mars Orbiter mission. He has been awarded ISRO Team Excellence Award in 2006 by His Excellency, former President of India, Dr. APJ Abdul Kalam, for in-orbit management of spacecraft operations. His additional technical interests include missile detection, AI terrain navigation, guidance, pulsar navigation, space re-entry, Mars exploration, and interplanetary missions. And he is here to give a keynote on telecommunication, navigation, and remote sensing of Moon. Let us welcome Dr. Kumar. Thank you for joining us today. The floor is yours.
Thank you, Ms. Mandal. And I should thank the organizers for giving me opportunity. So I was thinking, yeah, it is a very nice initiative by Moon Blaze of India to give a talk. However, my role is changed from being technical towards management and promotion. So I will try to tune my talk in such a way that what can be done on the moon to colonize the moon, basically. That will be the thing. I would like to share my screen. Can you please tell whether it's visible to you?
Yes, we are able to see your screen.
Yeah, okay. And I should compliment the Moon Blaze Association of India for coming out with such a nice idea to celebrate the landing on the moon. Yes, it is 53rd anniversary. Great. So what the title which I thought is the telecommunication, navigation, and remote sensing to the moon is very important, and we should have a dedicated navigation to go there. If tomorrow you want to colonize the moon and wants to put your habitats, these are the important parameters. So just trying to see what all verticals ISRO is working, and InSpace is championing that. And what are the geospatial applications? The similar should be replicated at the moon. So I have little bit touched upon the thing what Chandrayaan 2 has done already. Then how do we navigate to moon? And finally some figures on moon habitats. Won't take more than 25-30 minutes. So basically, these are the verticals where ISRO is working and have successfully demonstrated the capability where PSLV, GSLV Mark III, SSLV is coming shortly. Then we are in communication, navigation, Earth observation, fleet of satellite. I think it is largest fleet, around 50 plus satellite we have, and space science missions. We have one satellite Chandrayaan 2 about the moon and Mars orbiter mission. They are giving their value pictures, and analysis are being done. So there are certain things which are okay. I'll move on to the next. And these are the basically developments in space applications where it is touching the lives of the people in everyday life. So why I put this slide is not the same way the moon also should be captured every aspect. I think certain things are already done. Many craters and other things are identified. And same way remote sensing, when you do of the moon like Earth, you can do many things there. And with the high resolution images should be the requirement. What's on the Earth is the value of space. This report, I liked it. I recommend you should read and give your comments. I was just seeing one interesting chart in that which country has the more interest in space. You see India is 24%. So this is the kind of thing where India shows interest, and this report was published on 30th June by Inmarsat. So I'm just saying that this is a typical GPS constellation where you have 24 satellites in 6 planes, and anyway, this is well known. I'm telling that navigation is important to find your position. Same way, our own Saptarshi constellation, which is giving a good navigation service. So the purpose of this thing was to the same way we should have a navigation at moon also. I have some of the concepts which I liked that was by ESA. I will come back to there. So mathematical part will remains almost same, which we can do. Now, if you see the remote sensing, we have various kind of constellation about Earth. Moon, I think we have presently 4 satellites only. So we can have formation of the satellites, and we can really study the moon well. And India was the first nation who Chandrayaan could find the water on the moon. So now we have to develop it more understanding of the moon, and I think some of the companies, big companies like Blue Origin and all are going to the moon. I will show you some of the charts. This was I should say proudly that Chandrayaan captured this Saravai crater, and they identified, and this was named as the Saravai crater. So this is the kind of thing where you have a lot of craters, and you have to say when you go to the moon. So it's all the more important that we should do remote sensing of the moon and find out each hurdles or craters or this thing. So we have been working on this. One of my team was use the fuzzy logic techniques to determine the craters or hazard detection and automatically move the lander to the other place. I'll share that paper towards the end. So inter-satellite communication is also important aspect where you communicate from ground to moon and in between while you are going. So navigation is required to be there from Earth to moon and around the moon. So there are some nice concepts which are coming up. Otherwise, we have to use delta DOR techniques to find the range or to navigate to the moon. So this has come a very nice concept of navigation. I will touch it subsequently. You see here, okay, some of these are the missions planned by some of the space agencies, and there are some commercial missions. Some are already there, and some will are planned for the coming years. I think there are the delay in some of the agencies which have been postponed because of COVID and all. And you see that many nations are coming forward, and they are doing a good job. And I really see the SpaceX, Blue Origin, ISRO also, we have Chandrayaan 3. Artemis is a very nice this thing, which is going to be a very great mission, which we can see some fruits coming shortly. So I would like to touch upon how we went through Chandrayaan missions. So when you see that's first we are raising the apogee. So apogee is the farthest point where we carry out the maneuver as perigee. So we went in some 4 or 5 maneuvers. We went up to the 1 lakh kilometers. Then we carry out the lunar transfer trajectory, and you see that the moon is traveling in the right direction. So at this point, when moon reaches this, the precision is required to do lunar orbit insertion, where if you miss that opportunity, your craft will go to become a interplanetary object. So that's a very important point where we did, and finally we captured the moon. So this was followed in our both the missions. So this is the way finally you go about the moon. So during this period, we have to carry out the delta DOR. But in future, we can see that by constellation of the satellites or making GPS or Navig satellite looking towards space, we certainly can have the navigation techniques, and we can find the position at any time and carry out the maneuvers. Just a short video of it is a very nice initiative by AGI and ISRO, where you see that how we went and under various phases and went around moon. So after separation of Silda and all that, it is in the orbit. and then you carry out the maneuvers in space. So Paris 1 is happening. So like this, we continue to do the burns. So each stage, the more you go farther from the Earth, so each disturbance, each cluster firing has to be accounted for, and navigation becomes a very important aspect. And when you go, then you have to establish the communication with deep space antenna at our Bengaluru, and of course we use the further delta DR capabilities of US, where you have farther both the side of the Earth to two antennas positioned at the ground for the geometrically separate places. So then we carry out the lunar ones, and we finally go to the orbit. And after a couple of months, you see that we come to within 100 kilometers of required things. So this is the way orientation of the antennas to download the data. Then this was the in Chandrayaan 1 when we have sent the moon impact probe, which was very successful. And so this is just a nice animation I thought I'll share with you, and wherein we could, yeah, it is done. So I'll move on. So this is the Chandrayaan 2 phases where we continued in the same way, and we inserted to the lunar orbit. And after coming to 100 by 100 kilometer, we carry out the this thing maneuver to lander, bring the lander into 30 by 30 kilometer and start the autonomous landing sequencer. Yes, we went very near, but there was some glitches because the hardware, and yes, we could not succeed in that attempt, but all things are taken care. Future, we will have a very successful flight. So these anyway I have discussed in that, what are the sensors and other engines were used during that time, and till end our things were well matching, but for some issue with some hardware and all. But anyway, the committees already submit the report. I need not talk about that. Yeah, this is the concept which I like that ESA has given for the moon, where this is the navigation at the moon, and you can find the altitude also using the navigation anyway. So you see there around 10 or 11 satellites constellation will be formed, where they will be having inter-satellite communication. And through this inter-satellite communication, you can find the position. So when you are planning to make a habitat at the moon or someplace, so you need to find where your position is, where you are on the moon. So that will all the more important, and you should have a continuous communication with the Earth. So that will give you the many kind of much satisfaction rather than being the alone. This work can be taken up, and these all formulations and all are available. You can refer my papers if some student is here to do this further. But that is in the context of NAVIC. But here we have to change accordingly for the Moonlight Initiative to find the position at the moon surface. Yeah, this is the another thing where these satellites which are fixed around the moon can communicate to the Earth, and you can have the direct communication and navigation. These are the certain things. When you have all this, then your landing on the moon surface becomes very easy. Yeah, everything is your proper altitude control and the landing, plus the high resolution images of the Earth, sorry, moon, are required so that you are not getting into any trouble of getting into crater or boulder, etc. So you will have anyway launching pads there or landing pads also. So this is a very important aspect on which many countries are working, and we should also give a bit of our hands in that. And I'll see here that I found very interesting images on the moon where they are having the moon habitats. So these habitats are very interesting, so because there is no atmosphere and that, and certain parameters which we should have on the earth are not available. So we will have this kind of caves or this kind of habitats. But you see, when it becomes a city left side, it looks so good. So I will just say here, thank you. And I will share one paper now with you. Can you, how to stop the pause here?
Yeah, to the top, you can say option to stop sharing the screen.
Coming pause here and you share, right?
Yeah.
I will do this, yes. I think you can see this thing. So where basically it was in CLAX 2021 we are doing while I was in URSC. So this is one with university thing, the deep semantic classification of visual impacts hazard-free lunar landing. So basically when you use these techniques, I'll go directly to the results. All details are given here. When we carry out the semantic segmentation, followed by we make the segmentation map, and then we carry out the graded classification. So when you see like this, it does in between steps, and this image segment ground truth we are having on board, and we try to create. And what we did, we carry out the thorough analysis of this, and when we found that it predicts safety thresholds. So this table gives the, when you want to go, it will tell you in advance that whether you are going at right place or wrong place. So those figures we have given, and when we have tried to land at that place, what the safety threshold we have defined, and see at 2 places it has said the false, or other places true. So basically what I mean to say is here is that these are the techniques and which are going in a great way, and people are studying all these things in India also, and we should basically participate in that in right spirit and work for its success, so that that is possible in a some time, maybe in a decade or half or so, that we have colonization of moon, or it can become a stepping stone to the other planet. We can go to Mars, we can stay there overnight and move our journey forwards. So for these aspects, these 3 parameters are very important: navigation, communication in today's world, and the knowledge of the planet where you are going. So that's all. Thank you for now from my side. I can take up some questions if you have.
Yeah. Thank you, Dr. Kumar, for sharing us such a wonderful presentation about lunar remote sensing and other aspects of lunar missions. So I guess we have a question from the audience. So let me just say. So yeah, so we have a question on like, what are the current methods in communicating with landers going to the far side of the moon?
Yeah, so basically what happens, generally, that's what the idea to put that navigation part was this only. Presently what you are doing, you have the 2 antennas apart. From one is at Goldstein and one more, I think, Australia Goldstein, one more is there, US somewhere, 2 places, 2 antenna, and one you use the crushers. Basically, they are the radio sources. So you carry out the delta DR. That is the general method. But when you are the far side of the moon, you cannot see. And when you carry out the landing, which ISRO did, so it has to be autonomous. So what you do, you give the parameters generally into the trajectories are put into the controls, this attitudinal orbit control electronics. where they execute automatically. So where truth and this is compared and trajectory is defined, the commands are given to land. So this is the kind of thing, because if you are landing on the moon, you don't have time to command, because your other side, your communication, other things you can't command also. So what you have to do is basically you have to build the autonomy. That was the other thing where we use star sensors, we use the sun sensor, all information used for altitude purpose and known trajectories. We carry out the Monte Carlo analysis of the trajectories and orbital positions, and they are put, and the command is given accordingly. And it is a local navigation. Basically, when you are going there, you have a various kind of sensor, like the primary sensor being fiber optic gyro is accelerometer we call, and after that, wherever we get opportunity, we carry out the calibration of these accelerometers or IMUs. The calibration is done to improve the accuracy. So for that, we can use the laser ranging and other techniques. So these are the things.
Yeah, so there is one. I mean, how much would a ground station on surface of moon support navigation?
See, now when you build a constellation around moon, constellation of satellite by 10 or 11 satellites. So what happens, and then you install as per the FOV of the place, maybe 3-4 stations go other side also, then your data can be transferred from the ground station to the satellite in vicinity, and then it can be communicated to the inter-satellite with a time stamping and position. So yeah, exactly this study has not been done particularly for that how many, but just once you have a inter-satellite communication of with a network of the satellite I have shown with the moonlight initiatives, it will be very easy. You can have a small handler like in a mobile also, you can find the position. Yeah. I think we lost your voice.
Yes, I mean, I myself have a question, Dr. Kumar. So yeah, from your experience working at ISRO, what role you think India is going to play in the future of lunar human settlements, be it with the government organization or private organizations?
See, I really see that the efforts of governments are tremendous in that, and ISRO has done a very good job. And many companies are coming forward to share hand. Last year, I have been to Dubai IAC 2021, where I have seen many nations has the plan for landers. They have the landers, there are the displays on that. I was very happy. India also can participate. And yes, there are the companies like Industride earlier also. So there are some companies, those who are hoping for it. And yes, in future, ISRO is also playing a part, but now private sector is also come up, and with the enabling of private sector, I am sure that Indians will go in a big way to support the colonization of the moon.
Yeah, so I guess that's all, Dr. Kumar. So we would like to thank you for such an enlightening talk with respect to telecommunication, remote sensing of moon. Yeah. Thank you, Dr. Kumar.
Thank you very much.
Yeah.